Hey guys, so today we'll be talking about trigonometric ratios. So we're just going to start off immediately. So the first thing we need to understand is theta. So theta is right up here. Theta is always going to be an acute angle, so that means it's going to be less than 90 degrees. And then if we look over here, so we have sine theta equals opposite over hypotenuse, cosine theta, which equals adjacent over hypotenuse, and tan theta, which equals opposite over adjacent. So I'm just gonna draw these out. So we're gonna assume that all of these triangles are 90 degrees, even though they might not be exact because they're just drawings. So that's the first thing that we're gonna do, and then I'm just gonna draw them out. So sine, so it equals opposite over hypotenuse. So we know that the hypotenuse is always gonna be the longest side. So the longest side of the triangle is this one. So this is hypotenuse. This is our hypotenuse right here. And then we're gonna, for our opposite, it's always gonna be opposite from the angle. So we have our angle right here and we're just gonna look right across it, right across it. So right here, and so this is our opposite. So if you're given an angle, you can, or any term, if you're given hypotenuse or opposite, you can find the angle, or if you're given the angle at one side, you can find either side. So let's say I was given this angle and the hypotenuse, I could find the opposite. Now we're going to move on to the second one, which is cosine theta equals adjacent over hypotenuse. So again, we know that our hypotenuse is going to be the longest side. So this is our longest side right here. And now we're going to find the adjacent. So the adjacent is always going to be, it's basically just not the opposite. It's just right below the angle. So this, we have this here. So our adjacent would just be right here. So again, if you have the adjacent and the hypotenuse, you can find the angle. Or if you had, let's say, the theta angle and you had the adjacent, you could find the hypotenuse. And then over here we have tan theta equals opposite over adjacent. So we're going to look for the opposite, which is right across, opposite. And we know that it's here. So this is our opposite. And now we have, let's say we're finding our adjacent. It's just going to be below the angle because we know that this is going to be our hypotenuse because it's the longest side. And this is our adjacent. This is our adjacent. So it's kind of confusing right now, but there's one really easy way to remember all of these, like everything that's in a box right here. So it's just like a saying. It's called SOHCAHTOA. So sine, this is our sine right here, equals opposite over hypotenuse, which is this. Cosine equals adjacent. Cosine theta, just remember that there's going to be the angle as well. Cosine theta equals adjacent over the hypotenuse. And then we have tan theta equals opposite over adjacent. So that's like one of the first steps. This is the basics. So feel free to pause if you're a little confused. You can also ask questions in the comments. I don't mind. And then just take your time to really let this sink in because this is like the basic. This is the basics. So you need to understand how to do this to do other things. And I'm just going to move on to the next thing while we're at it. So we're just going to do some identifying. So again, I'm just going to go through this, draw a couple of triangles to show what to do. So we have a triangle right here, and we'll draw a bigger triangle here. Just gonna assume this is a really bad triangle, but just pretend that they're perfect 90 degrees. So that all of these are 90 degrees, 90 degrees here, 90 degrees here. All right, and let's say we were given our angle, we were given this acute angle. So we're gonna need to identify, right, what each side is. So we know that our longest side is always gonna be the hypotenuse, and it's always opposite of the 90 degrees. So this is 90 degrees, so it's the opposite. And this is always gonna be the longest side. The hypotenuse is always the longest side, just remember. So this is our hypotenuse. And now what I like to do is I label the opposite first. So we got this, this is our acute angle because it's less than 90 degrees that we're given, and we would find the opposite of this. So the opposite of this, we're gonna go from the corner, look across, all the way across. So this is our opposite. And last but not least, we have our adjacent, which is with the angle. So right here, it's with the angle. That's why I like to how I like to remember it. And now we've successfully identified our first triangle. Second triangle, we're going to do the same thing, but instead we're going to flip it around. So we are given this angle. Let's say we're given this angle instead. Like most scenarios, we're given this angle, but now we're going to switch it up. So same thing. Let's see. Our hypotenuse is always the longest side. So let's look at the longest side, and it's always opposite of the 90 degrees. So this is our 90 degrees. A square indicates that it's 90 degrees. And we go across from it. So this is our hypotenuse. So first thing, we're going to get our hypotenuse out of the way. Second thing is we can do our opposite. So our opposite, we're given this angle. We're going to look across. So this is our opposite. Opposite, it's right here. I don't know what's going on. My mouse is still a little bugged, but our opposite's here. And let's look at our adjacent. So our adjacent is with our acute angle. So that means adjacent is here. So this is the first step. So we're going to do some practicing for identifying, because you need to be able to identify what's what in a triangle to be able to use those trig ratios. So give me a second, I'll be back. So these are practice questions. So what you're going to do is you're going to label each one. So label what the hypotenuse is, label what the opposite is, and label what the adjacent is. I'm going to get right into it, so feel free to pause before you check your answers, because that's one way you learn and that's one way you practice. So we're going to start off with this one, because yeah, I just want to start off with the left-hand corner. So we're going to label what this is. So we're given our angle. It's this on this side. So our angle is given on this side, and we're going to look right across to find the opposite. So this is going to be our opposite. So you don't have to solve it in this specific order, but just do what's most comfortable for you. And I already know that the longest side is the hypotenuse. So our longest side right here is going to be hypotenuse. So this is our hypotenuse. And this is our adjacent, because it's with the angle and it's not the hypotenuse. That's how I remember it. So adjacent. Now we're going to move on to the second one. So we're given it on the top right corner. So let's just find our hypotenuse first, because our hypotenuse is always the longest side. So it's still this side because it's the longest. Hypotenuse. Our opposite is opposite of this angle. So we're going to look straight down from this, make a line from the angle. So this is our opposite. And last but not least, we have our adjacent. And we're going to move on to this side. So these images are just like flipped around, they're moved around. So it's just like practice and like see it in like a different way. So longest side still is the hypotenuse. So this is our hypotenuse. All right, so we're going to look for the opposite. Let's say we're given an angle here. So we look down, and this is our opposite. This is our opposite right here. Opposite right here. Nice. And then we have our adjacent, which is going to be here, because there's the angle right here, and it's with the angle. All right, we have another one. This is our last one. So hypotenuse, still the longest side. It never changes. It's always going to be the longest side. We're given our angle here, so the opposite is right across from it, directly across. So we look across. This is our opposite, and our adjacent is going to be our last thing. So hopefully you got these right. If you didn't, go back, do it again, try it again. Make sure that you understand this, because this is going to help you a lot. Well, this is how you're going to be able to solve for these things in math. So yeah. All right, so now moving on, we're going to do a practice problem just to solve. There's only going to be one practice problem today, because I'm a bit short on time. But hopefully this will be able to help you get like a general understanding. So right here, we have angle x equals 90 degrees, angle y equals 20 degrees, and xy equals 4 degrees. So we're going to solve, so in this question, we're going to solve for all the points. So we're trying to know what angle each point is, and how much in length each side is, how much distance there is from each side. So our x is our 90 degrees. So we know that this is gonna be our 90 degrees because it's the straightest. This is just a reference. It's not perfect right now. It's not a perfect 90 degrees, but it's just a drawing for your own reference. So that's that. and their angle y is 20 degrees. I'm just going to make this 20 degrees. It doesn't really matter what side you make as 20 degrees as long as you know what you're doing. So this is our 20 degrees. That means this is our y. And x to y is 4. So x to y, so this is going to be our 4. So that means that z, or z, whatever you want to call it, is going to be on this side. So now what we're going to do is, there's a few things that we're going to do to solve everything. So after labeling everything, drawing out a triangle, labeling everything, you're going to want to find one side and then find the other side. So right now our options are to find, from here, we can either find the opposite, because this is going to be our opposite, or the longest side, which is our hypotenuse. So for me, I would like to find the opposite first. So we're going to write, so one way I would do this is always write SOHCAHTOA down, like as soon as you have the test, because this is really going to help you out, so you don't have to think. You still have to think, but it's gonna make your life a lot easier. Usually some people remember it by heart, but this is good. So we are gonna find, because we're provided, so we're gonna look at this and let's see what we're provided. So we're provided an adjacent and an angle. So that means the first thing that we could find is, we can either find the hypotenuse using cosine, because we already have our adjacent and our cosine theta, which is going to be our 20 degrees, or we can find our opposite with tangent theta and our adjacent. So I'm just going to start off using tangent theta equals opposite over adjacent. So we're going to write down the formula. So tan theta equals opposite over adjacent. So just a quick reminder, feel free to pause the video if there's any confusion. Also comment, ask for help. You don't want to be struggling. If you're going to be struggling on a test, then this is going to be very bad. You want to try and do your best. So make sure to ask for help. The teachers aren't actually that scary. So just, most of the teachers are really nice. They're really chill. So make sure you ask them if you don't understand anything. So 10. So now we're going to fill in everything. So our theta is 20 degrees because we're given 20 degrees. 20 degrees. And our opposite, we don't know what our opposite is. So opposite is still unknown. So we're just going to leave it as opposite. And we're going to fill it in. We're going to fill our adjacent in. So we know from x to y it's 4. So this is our adjacent because it's with the angle. This is our 4. So now what we're going to do is we're going to solve this. So how are we going to solve this? So we're going to need to isolate opposite. So the way I would do it is I'm going to get rid of the denominator. So I'm going to multiply by 4. So if I multiply by 4 on this side, I have to multiply by 4 on this side. So now you need a calculator for the trig unit. So make sure you have one on you. So you're going to plug in, well, every calculator is different, but for me, I can just plug in 4 tan 20 and I get my answer. But some people you might need to put brackets, just make sure you know how to use your calculator so you don't get it wrong. But after I plug 4 tan 20 degrees in my, well, you don't have to write 20 degrees. You just plug in the number and then you'll be fine. And my answer, I get 1.4556800937. So we're just gonna round this up because I'm not writing that many numbers. So usually teachers want you to round up to the first or second decimal place. Just make sure it's reasonable. So I'm just gonna do the second decimal place. So 1.46, because this is a 5, so we're gonna round up 1. So 1.56, 1.46, my bad. So now we know that our opposite is gonna be 1.46. This does not look like 1.46, but this triangle isn't going to be as steep. I just drew it like that, but you can just use it as like a kind of like a reference, but it's not 100% correct, like the drawing itself. All right, now moving on. We still need to find our hypotenuse. So to make this more accurate, I would not use the opposite side to find the hypotenuse. So I would use cosine. So this is c, so ka, so we're going to use ka. We're going to use ka. So cosine theta equals adjacent over hypotenuse. So just going to write that out. And now we're going to fill in the blanks. So fill in what we know. So we know that cosine theta, we know our theta is 20 degrees. So 20 degrees right here. We know our adjacent is 4. And our hypotenuse is unknown. So we don't know what our hypotenuse is. So what we're going to do now is we're going to move our variable around so that it can be isolated. So what I like to do, because I always make mistakes with this, is I always want to remember to move I'm just make sure that your denominator isn't your hypotenuse. So what I would do is I'd multiply everything by hypotenuse first. So I'm running out of space here, so I'm just going to write it. So hypotenuse times cosine. So this period means multiply. You'll probably see it more later on in math. But cosine 20 degrees equals 4 over hypotenuse. So that's our hypotenuse times hypotenuse. So the hypotenuse and the hypotenuse are going to cancel out. And now we have a hypotenuse over on this side. So we still need to isolate it, right? So what we're going to do is we're going to move the cosine 20 degrees over to where the 4 is. So to be able to do this, we have to divide, because right now it's still multiplying. Cosine is multiplying. So we're going to equals, this is our equal sign. We're going to divide 4 divided by cosine theta, because if we divide cosine 20 from this side to cancel out, that means we need to divide cosine 20 on this side. So 4 here, I'll just write here 20. So 4 over cosine 20 degrees. So now what we're going to do is grab your calculator again. So we're going to plug in 4 divided by cosine 20. Yep. So, and your answer for the hypotenuse should be equal to 2, no, not 2, 4.256711109. So I show as many digits as my calculator shows first, and then do all the rounding. So it's approximately, oh, sorry, for this, I'd make this like approximation. Just like show your teacher that it's not exact, because it isn't. So I'd round up to my second decimal place again. That's what I would do, to 4.2, and there's a 6 here, so we round up 1, so 4.26. 4.26. And we know that this is most likely correct is because, well, we've already done it. We've already done all the equations. But one more thing to notice is that our hypotenuse is always going to be the longest side. So as you can see here, right here, we have our adjacent, which is 4, and our hypotenuse is 4.26. So that's how we know we're correct. And now let's say we're going to find our last side. So we don't know what this angle is. We don't know what this angle right here, angle on Z, is unknown. So a triangle, we already know that a triangle is going to be 180 degrees. So 180 degrees. And we can just subtract everything. So we can just subtract our 90 degrees, because we know that this is 90 degrees. And we can subtract our acute angle, which is 20 degrees. And our answer we get is 70 degrees. So we know that 70 degrees. So we know that angle Z equals 70 degrees. So yeah, that's how you do this part, and that should be it. So I'm just going to go over one more thing, And this is like the applications for trigonometric ratios and just like understanding things because we use this a lot in real life, and there's a lot of other things that we need to know when we calculate this. So you might get like a couple of word problems that talk about like angle of elevation and angle of depression. So these are going to only be for right triangles, of course. So I'm just going to draw this out. So we have, let's see, I'm going to make some straight lines so it's easily understood. So we have a straight line right here. Oops, not very straight. Straight line right here. All right. And we'll just have like, we'll just show this. We're just going to draw it out like this just to show you. So right here we have, this is going to be our angle of elevation because we're looking at like an elevator. So elevator, you go up, well, just think of it as you're going up on an elevator. And so let's say you're here, the observer. Oh, sorry. All right. We're gonna draw a little happy face person. A little happy face person. He's just pretend you're. I'll move this. I'll just erase this. All right. So you got your person. Okay, this is you. Just pretend. That's a smiley face. All right. And you're looking up at something. Maybe like a tree here. Maybe like a bird. And now this is gonna be your angle of elevation. So this is your angle right here. So whatever you're looking at, and this is going to be your line of sight. So this is line of sight. Line of sight. Now, this is your object, whatever it is, maybe at the top of a tree, maybe a bird, and this is usually height or perpendicular distance as they call it. So this is, we'll just say this is height. Well, it could be different each time, but if you're using this in real life as like a real life application, it might probably be height, most likely. And this is your horizontal line, so this could be like distance. Usually it's distance, so like how far you're away from the tree, how far you're away from something. And yeah, so this I would just say I just call it a horizontal line. Horizontal line. All right, so moving on to our right triangle for angle of depression. So we're gonna draw our triangle. So let's say, you know what, we'll draw our little person first. So we have our very happy math person, very happy, as you can see, smiling. And it's a stick figure because I can't draw anything better than that. So that's our observer. So we're just gonna use him as our sample. So we got a nice little triangle here, and they're looking at something down below. So this something could be anything, actually. Let's see, so we're just gonna do that. Draw that out. It's kind of bad. This is supposed to more like a perfect triangle, but I can't draw. Drawing on a mouse is pretty hard. All right, so this is gonna be our angle of depression, and this is our line of sight. Line of sight. So line of sight. Line of sight. This is our object. Let's just say it's like a little boat, maybe a little boat. And this is can be your height or perpendicular distance again. Height. And let's say this person's on a low cliff. So, and your horizontal line is here. So I'm not gonna write that out again, but yeah. So what you're gonna do in these situations is, I know a lot of people go straight off, oh, they get an angle and they just base it off of that, but that is not the correct thing you want to do. So if you look at here, there's actually another triangle here and there's this angle. So let's say we're given this angle as 20 degrees. So this is going to be our angle of depression. So you actually need to subtract that from 90. You can see that it creates like a 90 degrees. So 90 minus 20, so this is 70. So this is what you're going to base it off of. So say 70 degrees because you're looking down from this. and not this, if that kind of makes sense. Because you're looking, let's just say you're looking and you're using this angle. You're using the 70-degree angle, not the 20-degree angle, if that kind of makes sense. And yeah, and that's about it. That's about it. Good luck on your final. Make sure you guys study, practice, practice a lot of problems, practice all the problems that your teacher assigns you. Ask for help if you need it, right? Study ahead of time, which is really important. I would study 1 to 2 weeks before. If you procrastinate, then it's gonna be very difficult to get a good mark unless you already know the material, right? But even if you know the material, always make sure to practice because sometimes we think we know it, but there could be, on any test, it could be harder problems. Depends what your teacher does. All right. Thank you guys. Yeah. Peace.